Hi, this is Mr. Flamino. I'm going to take care of introducing section 4.5, Properties of Logarithms. In the last section, we discussed all the basics of logarithmic equations and functions, what their graphs look like, their inverse, how to solve some simple ones. And what we will do in this section is look a little more in depth so we can work with a few more styles of equations and really start to make some good connections with the exponential. Obviously, there are things in this section we want to know and want to be able to do, and when you get to class here, we'll get your essential questions, your objectives for this section to look at today. For us, though, we are going to jump straight into those properties. This title of this slide says Laws of Logarithms. I guess we could also call them properties. Laws and properties are kind of the same thing. And what we're going to do is we're going to start with a given here, and we're going to say these laws, these properties, only work if u and w are positive real numbers. If you don't want to write all of that out, you can go ahead and shorthand it as we've been doing. Remember, you are note takers, not copiers. You could write if u, comma, w are elements of the positive real numbers. So you can shorthand that big, long sentence into just a handful of symbols. And that's what good note takers and good students do. I typed it out because I had enough time. You as note takers probably should shorten. Our first property, it says logarithm base a of u plus logarithm base a of w is equal to logarithm base a of u times w. If we look at this in a little more depth, it says if I have two logarithms of the same base, it doesn't matter what the base is, there could be any base. I've denoted them with base A. If I have two logarithms of the same base being added together, I can condense those two separate logarithms into a single logarithm of the same base, keeping that base of A the same, and multiplying their inputs, u times w. Our second property is very similar. Logarithm base A of u minus logarithm base A of w is equal to logarithm base A of u divided by w. In this case, if I have two logarithms of the same base being subtracted, I can condense those two logarithms to a single logarithm of the same base and divide those two inputs. Our third property says if I have a logarithm base A with some input u that is raised to a power c, I can simplify that by taking the c and multiplying it by the logarithm base A of just the input u. Once again, the base of A staying the same on both sides of that equation. So those are the three properties that we are going to use. Before we move to the next slide, there's a couple of things I would like to point out. First being that with these statements of equality, like any statement of equality, they can be read both from left to right and from right to left. It was fairly arbitrary that I wrote logarithm base A of u plus logarithm base A of w on the left side and logarithm base A of uw on the right side. I could have very easily switched it. Most times we have to remind students that when we have a statement of equality, we have to choose it to write it one particular way, but it can be used in both directions. So I could use this statement, the property 1, to take two logarithms that are being added and condense it to a single logarithm, or using the right to left, I can go ahead and take a single logarithm and pull it apart to two separate logarithms that are being added. And that holds true not just for property 1, but also for property 2 and for property 3. So keep that in mind, that you may encounter situations where what is initially presented to you is the right side of that equation, the right side of those properties, not the left side. The second thing I'd like to point out to you, and you may have noticed this already, is that a lot of these properties, all of these properties, have similarities to our laws of exponents. That's because logarithmic functions are the inverses of exponential functions. So the laws of logarithms are going to have a lot of similarities to the laws of exponents. And if you didn't see it, let me just give a quick point out here. For example, in statement number 1, if I were to think about this exponentially, if I were going to multiply exponentials that have like bases, I would add their exponents. So if I'm thinking about this multiplication of this UW over on the right side, multiplying exponents, but multiplying like bases, I could add the exponents. And remember, the answer, the value of logarithm base A of u on the left, the value of a logarithm is an exponent. So logarithm base A of u is an exponent. Logarithm base A of w, the answer to a logarithm is an exponent. I'm adding two exponents together. Property 2, if we remember from our exponents, when we divide like bases, we subtract exponents. So on the right side, I have a division. The left side, I have a subtraction because of that rule. And property 3, I have a power to a power rule going on here. And when you raise an exponent to a power, you multiply those exponents. So if I look at the right side, if I look at the left side, c is in the exponent position. If I look at the right side, c is that same exponent value. And then the logarithm base A of u, we know that the value of a logarithm is an exponent. So I'm multiplying two exponents, really. And the next few slides is what we're going to take care of to really make that look proper there. And what we're going to do is we're going to take the three properties and we are going to prove them. Just so you know, one of these next three proofs will be on your unit tests. If you don't know which one, you just have to recreate it, but you're going to have to prep for all of them. The reason we're doing this is because you guys looked at proof structure and geometry. It's two-column proofs. Once you get out of geometry, mostly we use paragraph proofs and some structure on there. And you might encounter these in higher level classes. So we want to get you used to seeing those proofs. And so we are going to start with this statement for the proof of law 1 that says, let logarithm base A of u equal r, and let logarithm base A of w equal s. That's equivalent to setting up the givens. When you did your two-column proofs in geometry, you started with your givens. When we start with our givens in an algebraic type proof, we normally use the word let. So we have our givens, and then we're going to start working with them. And just like our two-column proofs, every statement we make has to be backed up by a reason. And so here, I'm going to change logarithm base A of u equals r into a to the r equals u, and a to the s equals w. And I can justify that by saying by the definition of a logarithm. I made a statement, a to the r equals u, and a to the s equals w, and I can justify that because I applied the definition of a logarithm to the givens at the start. From here, I'm going to say that u times w is equal to a to the r times a to the s. And that's just some basic substitution. If u is equal to a to the r and w is a to the s, then we would have that there. And continuing, uw would equal a to the r plus s, because when I multiply like bases, I am going to add exponents. You know, I could say this by laws of exponents. I don't think I need to justify which specific law it is, but we know that when we multiply like bases, we add exponents. And now what I've done is I've created a single exponential term on the right side of this. And so I'm going to rewrite this as the logarithm base A of uw equals r plus x. And once again, I'm justifying that by definition of a logarithm. I used the definition of a logarithm earlier to turn logarithms into exponentials. Now at this stage, I use the definition of a logarithm to turn an exponential into a logarithm. What I'll do from here is keep the left side exactly the same. Logarithm base A of uw equals, and I'm going to go all the way back up to my givens and say, hey, I've got an r plus s. But we saw that r was equal to logarithm base A of u, and s was equal to logarithm base A of w. And so I'm just going to, by substitution, rewrite that as logarithm base A of u plus logarithm base A of w. And my justification would simply be by substitution. And the final line is the law. This is the property we were trying to prove. So I'm done. And normally you end a proof with either a box or an X or a QED or something like that. I like the shaded box. And that tells the reader, I'm done. And that is the end of the first proof. So once again, we used the laws of exponents to prove a property of logarithms. And so now we know it's true and we can use it all the time. The following two proofs are going to follow very similar. So the proof of law 2, get this out of the way. I'm going to expand this so it's a little easier to read. Starts with the same given. Let logarithm base A of u equal r and logarithm base A of w equals s. From here, excuse me, I'm going to go with the same use of the definition of logarithm to rewrite the logarithms as exponentials. A to the r equals u and a to the s equals w by the definition of a logarithm. And what you will do there, remember, every statement that you make, you need to justify. You can't just make a statement and walk away from it. You have to justify. And this is the same as your two-column proofs having a column for statements and a column for reasons. So I use the definition of logarithms to turn my logarithms into exponents. And I'm going to follow a very similar structure to my last proof. The last proof I started with u times w. Here I'm going to start with u divided by w because that's what property 2 looked like. That will be equivalent to a over r divided by, a to the r divided by a to the s. That means u divided by w is a to the r minus s, and that's going to be by a law of exponent. So you can see, maybe some of you are noticing that it's very similar to structure last time. I'm going to rewrite this exponential as a logarithm. Logarithm base a of u divided by w will be equal to r minus s by definition of a logarithm. And then I can substitute my r and my s just like I made my rs substitutions last time so that I get logarithm base a of u divided by w equal to logarithm base a of u minus logarithm base a of w. I should justify that. I'm just going to say simply by substitution like I did before. And just like before, I have the property I was trying to prove as a true statement at the end. So my proof is done. So two proofs, but the same setup, the same structure, the same way of writing. Our third proof, this is going to get a little boring because our third proof uses the same idea. Now I have this in here. I actually do not need all of this because the third proof did not have a second logarithm. So I actually only need that piece right there. So I'm going to let logarithm base a of u equal r so that a to the r is equal to u by definition of a logarithm. I can raise both sides to the c power just because I'm allowed to raise both sides of any equivalent, any equal statement to a power. That means I get a to the rc equals u to the c. And that is going to be based on laws of exponents again, power to a power rule. And now here comes the tricky part. I am going to want to rewrite this as a logarithm, just as I had done before, but I have an exponential on the left, base a, and I have an exponential on the right, base u. So I could either rewrite this as a logarithm base a or a logarithm base u. I'm going to write it logarithm base a because if I look back at the property involved a logarithm base a. So this is going to be a logarithm base a of u to the c is going to equal to rc. Well, I'm going to take that rc. I'm actually going to rewrite that, since multiplication is commutative, as cr. And once again, we already knew that r was equal to a logarithm base a of u. So I can make my substitution. I get logarithm base a of u to the c equal to c times logarithm base a of u. And I'm done. Oh, I should put some couple of justifications in here. See, this one right here would be by definition of a logarithm. And this one, as usual, will be by substitution. And I'm done. I got the proof that I was looking to prove. I got this logarithm base a of u to the c equals c times the logarithm base a. And I've got what I was looking for. So those are the three proofs of those three laws. When you come back to class, what we'll do is we're going to pick up with a couple of warnings, a couple of things to be careful with. And from there, we're just going to get into some examples of what you would do with these properties. Hope this was helpful. Please refer to it as you need to help you study, and remind yourself whenever you need to. Thank you.